All right, the most straightforward way that attackers have of accessing this machine is by logging in via some existing user. So the first thing we have to do is we have to change the password for each of our users. The most straightforward way of doing that is running the passwd command. But before I go ahead and do that, I want to really quickly check and make sure that that passwd command hasn't been backdoored. So the way I'm going to do that is I'm going to say which passwd. That's going to tell me the file that's actually run when I run the passwd command, right? And in this case, I can see it's in user local bin passwd. I can learn a little bit more about that file by saying file to see what file type it is, right? Bin passwd, specifying the full path. And in this case, it says that passwd is a born again shell or bash script and ASCII text executable. That's a little bit unusual. I would expect this to be a binary file. So why don't I go investigate this and learn a little bit more about it. I'll just print out the contents. So if I cat out user local bin passwd, you'll see this is actually a bash script that sends any password that you enter to the attacker. So this is bad. I'm going to want to remove this. But before I go ahead and remove it, I want to see if maybe there are any other legitimate copies of passwd on my system. So one thing you can do on some machines is do where is passwd. And this tells me all of the locations where passwd is on my machine. This includes user bin passwd, which is not the same as user local bin passwd, right? So let's take a look at that one really quickly. If I do file on user bin passwd, this one says it's a setuid 64-bit executable. So that's what I expect that passwd file to look like. So it's quite likely that this passwd file is legitimate. So because I have this one, I can remove this script that's here. So I'll say sudo rm user local bin passwd. If you weren't entirely sure, you could, of course, just remove the execute permissions on it. So you could say chmod -x, or you could just say chmod, I don't know, 000, then nobody's going to mess with it anymore. But you can always change it back in case it actually was necessary. But in this case, I'm just going to remove it. Okay, so we're going to have, so now if I do which passwd, now it looks like it's using the correct passwd file, which is in user bin passwd, right? So now I can go ahead and change my password. One thing I should note is if Red Team is being extra mean, they could actually write code that would change your password but still send them a password, and they can compile it. So it is in fact a 64-bit executable. That would be really hard to notice, and so I feel like Red Team is not going to be quite that mean. So I'm going to assume in this case that because it is that's a 64-bit executable, we're good to go. So I'll just use passwd. I have to enter my current password, and I'll change it to something secure. So I'm using a combination of uppercase, lowercase characters, numbers, and symbols. I actually have a public password that I like to use for things that I don't mind exposing out there on the internet. So if you have something like that that's a secure password that you don't mind exposing, that's a great thing to use here. Another thing that I'm going to do is I'm going to switch to any other user that needs to be able to log in, right? So for example, root. So if I switch to root, I'm going to need to change root's password as well. Remember that root has a different path than user has. So again, I'm going to have to do which passwd to see which file is actually going to be run when I use the passwd command. In this case, user bin passwd looks good. We already looked at it earlier. So I'll just change my password here. Again, I'll pick something secure. I'm going to stay as root while I'm doing the rest of the things that I need to do so that I don't have to keep typing in sudo. Of course, this is not a best practice, so it's kind of up to you if you want to follow best practice and actually use a user that can use sudo, but just for the sake of setting this up as quickly as possible, I'm going to use root. All right. If there are any other users on my machine that are legitimate and that I need to keep, I could change the password for those users as well. Let's say the instructions said that I can't change the password for the jrice user. So that one I'm not going to touch. That's a scoring user. So we're going to leave that the same. Now that I've actually changed my passwords, I want to go ahead and check and make sure that everything's working properly there. So I'm going to exit out of root for a second, and I'm just going to try to switch to root from user, but I'm actually going to enter root's password. So if I do a su, so that's rather interesting. When I ran this switch user command, it actually switched me directly to root without me having to put in my password. So that seems kind of funky. If you're familiar with how authentication and passwords work in Linux, it uses something called pluggable authentication modules, or PAM. And PAM is basically just a collection of different pieces of code or modules that each define how passwords are handled. And PAM also has a bunch of configuration files associated with it, and those are located in etc pam.d. Ideally, you'd want to go through all of these and figure out and see if there's anything weird about them, but that could take a lot of time. So we're just going to look at the most common ones that would affect the switch user utility. So that's going to be common auth, which is responsible for authentication, and the su file, which is responsible specifically for switching users. So if I edit common auth, you'll see that there are a couple files here that are actually commented, or sorry, there are a couple lines here that are actually commented out that may be necessary. The only line here is auth required PAM permit. So that's what's actually letting us log in without having to put in a username and password. Before I edit a sensitive file like this, I'm going to make a backup of it. In case anything goes wrong, I can always then restore the backup. So I'm going to take common auth, and I'm just going to move it, make a copy of it in root. And then in case I make changes to this and something's not working, authentication isn't working properly, I can always copy that file back. Anyway, I'm going to edit common auth here. And I'm guessing these lines are supposed to be uncommented. If red team's really mean, they could delete them entirely, but in this case, they're just commented, so we can easily uncomment them. And now if I try to switch back from user to root, this time it actually asks for a password. So I'm going to make sure that I can't just enter any old password. It actually needs the one that's root's password, right? And then the other thing is I'm going to make sure that root's password actually works. So depending on how mean a red team is, they could edit really any of the files here. In addition to that, they could create a custom or their own PAM module that kind of gives them a master password that they can use to switch to any user. Or rather than creating that themselves, they could find that on GitHub. Hopefully, we're assuming red team's not that mean. That's something that would be really hard to check for. So if we can switch users by putting in their password and that password is actually required, we're going to assume we're good to go there.